Hello, everyone. Good day to all of you, distinguished speakers, guests, and attendees. First of all, I would like to say thanks to the Fourth International Conference on Computing and Data Science for providing this opportunity, and I wish them all the best for a very successful conference. Here is Prof. Tanzila Saba. I am the research professor and associate chair of Information System Department at Sultan University. Currently, I am leading the Artificial Intelligence and Data Analytics lab. Here is my brief introduction. So I have the Google H Index 63 and the citations, Scopus H Index, so you can find online. Today, I am going to talk about secured big data management for decision-oriented medical systems using Internet of Things, which is the very hottest research area and the topic in the domain of the healthcare informatics. So as all of us, we know the Internet of Things or the IoT is a very buzzword which is used in all the industries. However, in the medical system, it has shown a very incredible development with the growth of the smart medical devices. So when we discuss about the IoT application in the medical system, it is mainly known as the Internet of Medical Things, IOMT. So these are basically the biosensor that integrate with physical things to make smart healthcare applications that are collaborated on the internet. Many applications have been designed for the physical health of the patient and support expert team for appropriate treatment. However, it works very in the fast pace due to the remote mentoring of the patient and remote treatment. So the medical devices are attached to patient bodies and connected with a cloud computing system for obtaining and analyzing healthcare data. So the two main, I can say the domain or the areas are which we have to be highly focused when we discuss about the IOMT is the cloud computing and the healthcare data itself. So our main talk, the rest of the session, will move around these two topics and where we want to know in a more detail, in more depth, how it works. There has been a growing need for solutions that provide effective analytical tools. Most of the time, and I do believe all the whole research community agree to this point, that the selection of the technology, the application of technology is not anymore challenged right now. The most challenging point is to generate the accurate data and the analysis of that data, and the base of this analysis, how to get the insight from that data. So this pattern is evident in the examination of massive data set, which is known as the big data. Organizations are seeking methods to use the potential of big data to enhance their decision-making, competitive advantage, or company performance. Big data is believed to provide possible answer to public and commercial organization, although still we are not very sure how to protect the big data because still the vulnerability is there and the security threats are there. So even under value-based healthcare delivery models, healthcare management globally has shifted from a disease-centered paradigm to a patient-centered one. In order to achieve this model objectives and deliver effective patient-centered care, it is important to manage and analyze the big data in the healthcare. So I do believe most of us are very well aware about the big data and the journey of the big data and the evolution of the big data started from the 3 V's and then 5 V's. And right now, mainly the organization are working with the 8 V's, although there are the future is with the 10 V's and most probably with the new phenomena is with the 17 V's. But right now, currently the health organization is focusing on the 8 V's. I do believe in most of the research community are very clear about this. However, what about the volume is how much data is there. Organization, the healthcare organization must develop the storage techniques either on the premise or in the cloud to handle the amount of data on hand. Velocity is how quickly is the data being created, moved, or assessed. Healthcare information accounts for a respectable proportion of the data through the world's wires, and the figures will continue to rise as the Internet of Things, medical devices, genomic testing, machine learning, NLP, and other novel data generation and processing techniques involved. So, what about the variety? How many different types of sources are there? Variety may be the spice of life, but it sometimes be a little too much for healthcare organization to handle. Meaningful data comes in all shapes, sizes, and conventional wisdom that the most type of information you can smash together, the richer the insight will be. Now we come to the veracity. Can we trust the data? Trust may be even more important than access when it comes to the patient care. The veracity of a data set is difficult to verify, but providers cannot utilize insight that may have been derived from the data that is incomplete, biased, or filled with the noise. Now we come to the validity. Is the data accurate and correct? Similar to veracity, the velocity of data is a critical concern for doctors and researchers. A data set may be complete, but does it actually tell the user what is purports to? The most important other V is the viability. Is the data relevant to the use cases at hand, which I do believe is the most critical one? Correlation does not equal the causation. Data scientists are not willing to say understanding which element of the data are actually tied to predict or measure the desired outcome for producing trustworthy results. Then we come to the volatility. How often does the data change? As we know, with the huge amount of data, which we call the big data, it's changing on the per second basis. Healthcare data changes also quickly, some of the cases in seconds, so which raises the question of how long the data is relevant, which historical metrics to include in any analysis, and how long to store the data before archiving or deleting it. The most important phenomena, which is a very, again, the hottest area of the research, is the vulnerability. Can we keep the data secure? Security is a main threat, and most of the time with the AI and the machine learning and the deep learning, I can say that security is going parallel. So speaking about the data vulnerability, it is the wake of the multiple ransomware attacks and depressing long data breaches. Security is top of the mind for the healthcare industry, especially as the storage moves to the cloud and the data start to travel between the organizations as a result of improved interoperability. Then we come to the visualization. How can the data be presented to the user? Why do we need the data? Definitely we need the data to get the insight and for forecasting, making some future strategies. So in a busy emergency department or hectic ICU, for example, a clear and initiative data visualization may be the difference between utilizing and ignoring a key insight. So last but not least is the value. Can this data produce a meaningful return on investment? This is a question which each and every organization needs to consider and ask themselves. The only reason to engage in analytics in the first place is to extract some sort of value from the information of hand. Whether this value come in the form of the better outcome, improved business process, or smart strategic decision making, healthcare organization cannot afford to ignore the question about big data. What has it done for us lately? So this is an overall view of the big data, because our whole session, it's about the securing of the big data management. This is just an overview. The 4 V's of the big data, which again, and highly considerable in the healthcare organization: volume, velocity, variety, and veracity. Then we come to the Internet of Things, IoT. Most of us, we are much familiar with this concept. It is basically from connecting devices to the human value. So it divides the connection, data sensing, communication, data analytics, data value, and human value. So if we can generalize this interlink of the big data and the Internet of Things, it makes very clear then how closely they are related, how interdependent they are on each other, and how important it is to go in depth about this when we come to the new era of IoT, which is Internet of Medical Things. So here we talk about what is IoT and how does it work. IoT is basically the integration of the IoT in the medical devices in the healthcare field. So IoT based with the ecosystem component, which we will discuss in the next slide. Here, again, as I mentioned earlier, when we discuss about the IoT or the IoT, we have to be very clear about the cloud computing and the big data. And if you see this one of the case study, it is an IoT-based healthcare system. It is a data processing with the high computing machines, and where the machine learning and the deep learnings work, and the interfaces are there to get the result. Where different hospital, let's say hospital 1, 2, 3, or up to N, they are interconnected with each other. They are sharing the information, the patient data, and the EHR is working on the mainly on the cloud. Again, another example is about the patient, and they have the wearable devices with the smartwatch, smartphone, and how they are connected to the doctors, health centers, and the caretakers cloud to store patient health record, which we usually say the EHR, electronic health records, are available there. So I would, most of our research, currently in the real time, we did the research, which is the IoT framework layers. I would very quickly explain about this, like much like IoT, the Internet of Medical Things system consists of the following architecture layers. The first is the perception layer, which is represented by the range of smart medical devices collecting all kind of health data. The second layer is the gateway layer. Usually we label it as a connectivity layer. It's responsible for the data transmission from the perception layer to the cloud and vice versa. Through connectivity technology, networks, and gateways, where long distance and short distance wired or wireless networks are there. The third one is the data storage layer. Usually we call it as a processing layer. It's represented by the middleware or IoT platform to store and manage the data through cloud, fog, and edge computing, and the RAMs are there. The last layer is mainly the application layer. It is the deep machine learning, artificial intelligence, which previously we discussed about that. It's providing end user with the data analytics, reporting, and device control opportunity through software application. So IoT system components, you can see based on these IoT framework layers, how they made, and it's a network, the middleware, and the applications. So IoT and the cloud application, this is just an overview to maybe our attendees are some of the students, master PhD students who are mainly working in this area to get a very clear understanding how they are interconnected and how the main research can be done with the different concepts. So most of the time people use the IoT, when they talk about the IoT, they are using the cloud computing, edge computing, the fog computing parallel, although there is a very clear difference. Edge computing help devices to get faster result by processing the data simultaneously received from the devices. While what is the fog computing? Fog computing help in filtering important information from the massive amount of data collected from the device and save it in the cloud by sending the filtered data. So we can say edge computing is used to process time sensitivity data, while cloud computing is used to process the data that is not time driven. So in that case, I do believe it's a clear any concept. So we have come with the external applications. We have the healthcare professional, and here is the main cloud where all the data is stored from heterogeneous healthcare repositories, IoT devices, healthcare professionals. So this whole ecosystem, this is called the IoT ecosystem, which is interlinked with each other. An overview of real-time application Internet of Things at hospitals, how it works, how the wearables, and we collect the data, the required data for different diseases. The databases are built and the desktop manager is getting from the cloud, which is the EHR, electronic health record, and from the wearable devices, which come to the prescription to the physician or the doctor and the patient. And as I just mentioned, IoT is getting the most popularity due to the remote patient monitoring. So the data system structure in the IoT, we have the clinical data, we have study-centric, big data warehouses, repositories, and the most important again is the data visualization to get the insight, to get the value from the data, and medical apps developers are here. We have a lot of things. In the start of my presentation, I mentioned very clearly, nowadays the selection to get the technology is not any more challenging. The most challenging point is how to use this technology in the specific cases and how to save this technology. And the most important is how to get the most potential and the value from this technology. So when we come to the big data, these are just again in the main research areas where we can do the research, healthcare, big data and analytics application. We can use the diagnostic, patient treatment, precision medicine, which is again as a very popular and the most demanding research area, preventive medicine, telemedicine, health population support, medical research, and the cost reduction. So here we have some of the IoT big data and their analytics links. Here is the cloud, and you see the big data. All the V's are working together, coming up to the database, where we can prepare the report, the queries, the analysis tool, the selection, maybe the dashboard, maybe the graph, the charts, the Excel sheets, whatever is there, and the training data. Then we have the big data analytics platform, data capturing, data preparation, data pre-processing. Each one has their own application and the very important to work and to improve their area of research. Big data analytics and big data mining, and then the result of big data analysis. Due to the shortage of time, we cannot move into much detail, but in overall, it's very clear. Big data infrastructure, what are the big data sources? Wearable and RPM devices, health apps, medical equipment and other IoT devices, omics data, other sources, which comes to the data storage, analytical tools, and machine learning, deep learning algorithms work on it, and then we get the visualization interfaces. IoT adoption trends and influential factors. You can see the 60% of health organizations worldwide that have already implemented the IoT to some extent. Some of the health organizations are planning to implement it. Some of them have not decided to apply it yet. However, the factors that contribute to the growth of the IoT, the growing need for remote patient monitoring, high healthcare cost, the increased consume wealth awareness. However, now we are very clear what is the link among the IoT, big data, and the security, and what is basically the IoT, why it is needed in the most advanced era of healthcare informatics. So it comes now definitely with the IoT security and the privacy requirement. Their requirements are totally different from the traditional framework. Their main, which we usually say the CIA tried confidentiality, integrity, and availability. Most of us, again, we are aware about these concepts. So confidentiality, it prohibits illegal access to the specific data and guarantee the security of the critical information. While the integrity, it ensures that the data has the value, it has a consistency, and no unauthorized parties are able to edit, delete, or insert the device's data and the reading. Availability in healthcare informatics, specifically, it's very important, the availability of the data. So it ensures that data, computing components, and communications are accessible and functionable. Compliance, the most important, the IoT system complies with privacy standard and provides user with access to their private data. And these are vary from country to country because each one have their different rules and regulations. So how to secure the patient data, up to what level it should be accessible, it depends on the compliance of the rules. So IoT and big data implementation, they have some challenges as well. They have the technological challenges. Definitely, the selection of the technology, and the most important thing is the cost of the technology. And we have the SMEs, the same is applied to the healthcare informatics. So what they should choose, how they should apply is the most important thing. The expert issue, the staffing issue, the expert people who deal with this technology to create that culture, that environment is also an issue. Data aggregation and integration challenges, combining from the different sources, the data, and just to make sure that the data is valid, accurate from all these sources, and put them, arrange them in a specific format is also a big challenge. And definitely, last but not least, the most important is the data security and the compliance. So the healthcare industry deals with very sensitive personal data, which is carefully governed by the federal legislation. So there are different examples of GDPR and HIPAA. Consequently, maintaining data storage security, high quality encryption is essential and need extra work to ensure the privacy and the secrecy. While the big data challenges when it comes to the use of the data in healthcare, the question of big data use is often posed. It's the healthcare industry always created a vast volume of data, but to advent of electronic medical records, vast quantity of data supplied by the different kind of sensors are generated by patient via social media is causing data streams to rise exponentially. So how to manage these quantities of data, how to keep the clean data, the valid data, the viable data is a challenge for the healthcare industry. Healthcare organization will be able to assist clinical decision-making, diseases, monitoring, and public health management via the proper use of data. Who can access? By whom it should be utilized? For which purpose it can be used? So all of these questions are to some extent are the challenges in the era of the big data. So we have the IoT implementation challenges and solutions. So the most important are proposed by significant computer and software providers, Microsoft, IBM, Siemens, Gemalto. The criteria for safe IoT development comprise the three security areas: device security. When we're talking about the IoT, IOMT, mainly at the top is the device, refer to the process and tactics used to safeguard the device after it has been deployed in the field. Connectivity security, process and strategies for ensuring the confidentiality and integrity of data sent between IoT devices and the IoT hub or the gateway, cloud security. Now you see how they are interrelated and we cannot differentiate, we cannot keep them identical or separate. So cloud security refers to the protecting of data throughout its transmission to and storage in the cloud. Popular IoT systems such as the Microsoft Azure IoT Suite and the IBM Watson IoT platform addresses this problem and provide the standard security solutions. So these are some of our recent publication in the domain of the IOMT. So you can go through my Google Scholar link as well to search some of these. You can contact us through our either lab details. Thanks for listening. Feel free to ask if you have any question. You can find me at the Twitter, LinkedIn, or via email. Thank you so much. Have a good day. And thanks again for this opportunity.